Good morning, dear children. Today we are going to discuss a topic called heat capacity. So, earlier in this chapter, we have seen what is heat, what is temperature, what's the difference between heat and temperature, etc. Now, let's come to this topic that is heat capacity. And under this topic, you will study about increasing the temperature of a body by supplying heat to it. We all know that if you want to increase the temperature of a body, you have to supply heat. But how much heat energy is required to increase the temperature? That depends on certain factors. The amount of heat required to raise the temperature of a body by 1 degree, just by 1 degree, depends on the nature of the material. It depends on the nature of the material. For example, the amount of heat energy required to increase the temperature of water by 1 degrees will be different from the amount of heat energy required to increase the heat energy of iron by 1 degree. So it depends on the nature of the material. For example, if you take a cup of water and a bucket of water, the amount of heat required to raise the temperature by 1 degree will be different. That means it depends on the amount of the substance, it depends on the nature of the substance. And one more thing, it is easier to increase the temperature of water from 37 to 38 degrees. You may need a little bit heat energy. Same time, the amount of heat required to raise the temperature of same water from 97 to 98 degrees Celsius will be different. So there are many factors. That is what we are going to discuss today. So you take any amount of matter, a given amount of matter, the heat energy required to raise its temperature by 1 degrees is called heat capacity. It can be any amount. So heat capacity is the amount of heat energy required to raise the temperature of a given mass of a substance through 1 degree. That means I can write the heat capacity that I can mark as S. The heat capacity S is the heat by the rise in temperature. Rise in temperature I mark as delta T. The heat, small amount of heat, delta Q, required to raise the temperature by unity, that is our heat capacity, that I mark as S. So this is how I can give an equation for heat capacity, that is a delta Q by delta T. Now this is for any amount. Suppose your substance amount is 1 kilogram. So you take 1 kilogram of a substance, how much is the heat energy required to raise the temperature through 1 degree? This is known as a specific heat capacity. The previous one was heat capacity. This is known as specific heat capacity, because here you are specifically mentioning the amount of the substance, that is 1 kilogram or unit mass. That I represent with the letter C. Heat capacity, I told this is heat capacity. I mentioned it as delta Q by delta T and represented as S. And here I told if I take it for a unit mass, that is known as specific heat capacity, and that specific heat capacity I mark as C. So C is 1 by m delta Q by delta T. This 1 by m is coming to show that it is per unit mass. Per unit mass means this divided by m. So I can write C is nothing but S divided by m. There is a particular branch of physics that deals with this measurement of heat. This measurement of heat. This is known as calorimetry because the word calorie is known to you as the unit of heat. Let us be more specific, especially when it comes to gases. We will not express the amount in kilogram. We express the amount in mole, number of mole. So for that we have a term molar specific heat capacity also. Here let us check one more thing. Let us check the unit of this heat capacity or specific heat capacity. Unit of heat capacity S, its unit will be unit of S will be, this is heat energy expressed in joule, and this is in temperature, that is delta T. This is in Kelvin, that is per Kelvin, J by K. This is the unit of specific heat capacity. In addition to this, in the case of a molar specific heat, in the case of a specific heat capacity, C, its unit will be J, joule divided by kilogram Kelvin. So that's what here, joule per kilogram per Kelvin. Coming to our topic, that is molar specific heat, defined as the heat required to raise the temperature of 1 mole of a substance. Here we are specifically mentioning the amount of substance as 1 mole. So just 1 mole of a substance through 1 degree. So here previously for a specific heat, if the equation was 1 by m delta Q by delta T, we will replace it with this mass, we will replace with the number of moles for getting molar specific heat capacity. So the equation becomes C is equal to 1 by n delta Q by delta T, where n stands for the number of moles. Now let us see one rule, a particular rule, which is known as principle of calorimetry or law of mixtures. You might be familiar with mixing two particular objects with different temperatures. For example, hot water and cold water you might have mixed. Maybe in a bucket of cold water or normal water you might have poured hot water. The effect is the water in the bucket, its temperature increases. The hot water you poured, its temperature will be decreased. As a result, they attain a normal particular temperature, an average temperature. This is known as law of mixtures. And this law of mixture states that heat gained by the cold body must be equal to the heat lost by the hot body. That means the hot water will lose, previous example I am saying, hot water will lose heat energy, and that lost heat will be absorbed by the cold water. There is no exchange of heat with the surroundings. If there is no heat loss, if we assume, we can say heat gained is equal to heat lost. This is known as principle of calorimetry. We told already calorimetry is the branch of physics that deals with the measurement of heat. And there is an instrument or a device used to measure the heat, amount of heat, and that is known as calorimeter. So if you hear any word anywhere, calorimeter, that's an instrument used to measure the amount of heat. One important result of heating a body is change of state. Suppose you take water which is in liquid state, heat it well, it becomes water vapor. That means that the liquid form of water has been changed to gaseous state of water. You take a bowl of water, keep it in the refrigerator, in the freezer, it becomes ice. That means there is a conversion of state from liquid to solid. That's also by the exchange of heat. So when you supply heat or withdraw heat, You can even withdraw heat. That's what you're doing in while cooling. So in that case, in both cases, there is a change in state happens. And this change in state is what we are going to study. So as you all know, the change of state from solid to liquid we call as melting. For example, an ice piece you take outside the fridge, keep it in the normal room temperature, this will melt. So this change of change of solid to liquid, we call it as melting. And sometimes there is a change in liquid to solid. This process we call as a fusion. Normally we say it is freezing or fusion. Fusion is the correct name for that. Liquid to solid state, that means water to ice, that term we call as a fusion. There's a particular point, for example, there's a particular temperature. You take an ice cube outside the refrigerator, keep it in the air, the ice started melting. You can see that ice cube will be there, at the same time there will be water also, a little bit water also. There's a particular temperature at which the solid and liquid state of a substance coexist. This temperature is called a melting point. That particular temperature is called a melting point. Ice melt even in the normal temperature. Sometimes there is a change in state, that is from liquid to vapor. That's known as a vaporization. This process is known as vaporization. And the temperature at which liquid and vapor state of a substance coexist in thermal equilibrium is known as boiling point. That means at boiling point you can see both liquid and vapor state. That means when you make a cup of tea, when you make, at that time you can see water tea in the liquid state, at the same time you can see water vapor also. So at boiling point the liquid state and vapor state of a substance exist. There are situations in which you can directly change solid substance into gaseous state. From solid state to gaseous state you can change the state of a substance. For example, you take camphor, you can burn it, it goes into gaseous state. So this camphor is changing its state from solid to gaseous state. There is no liquid state in between, directly it goes from solid to gaseous state. This process is called sublimation. Sublimation, sublimation, sublimation. So melting point of different substance will be different. Depends on other conditions also, not only melting point, other all the state changes depends on, it's different for different type of material. The change of a state can be attained not only by increasing the temperature, but sometimes you can attain it with the help of applying pressure also. For example, ice cube, you take ice cube which is in solid state. If you apply pressure on it without giving any temperature, any heat, without increasing the temperature, without applying heat energy, you apply pressure on it. Because of the pressure, this ice can become water, liquid state. This phenomenon is known as a regelation. Regelation means by applying pressure, solid substance can be converted into its liquid state. This is what you see in ice skating. You might be familiar with ice skating. There, when you are running on this skating surface, ice surface, you can see water will be formed there because of the pressure of your body. Because of your body weight, there is pressure. That pressure will give the ice some force. As a result, this ice will melt. Once you pass over a particular place, again this water will become ice itself. It will freeze there. So keep in mind that name. Another one important point which you need to remember is a substance boiling point depends on the pressure. The boiling point increases with increase in pressure. It decreases with a decrease in pressure. And this point is used in the case of pressure cooker, where you can cook easily. How is inside the pressure cooker, pressure will be high, so immediately you are able to attain the boiling point of the substance increases. You can easily increase the boiling point, and you can do it the cooking easily. And same is the reason why it's very difficult to cook in mountains. Pressure will be lower there. Now let us familiarize another name, that is latent heat. We discussed about changing the state of substance from one state to another state, changing it, that we have seen. And the heat energy is required for that. The amount of heat energy required to change the state of unit mass can be 1 kilogram. Unit mass of a substance at constant temperature and pressure. This is called a latent heat. That means how much heat energy is required to change the state of a substance, a unit mass substance, 1 kilogram of a substance, to another state, from one state to another state, maybe from solid to liquid, liquid to vapor. Likewise, for state change, how much is the heat energy required per unit mass? That is known as latent heat. We represent this latent heat by the letter L, capital L, and which we can write as an equation, that is Q divided by M. If Q stands for the heat, amount of heat energy, and M stands for the mass available. So when you divide Q by M, what you are getting is the heat required for unit mass, 1 kilogram, and its unit will be joule per kilogram. So depending on the different process, for example, we discussed about fusion, we discussed about sublimation, even we have vaporization. We have different latent heat also. Latent heat of fusion means heat energy required to change unit mass of a substance from solid to liquid. Similarly, latent heat of vaporization means heat energy required to change the substance from its liquid to vapor state. That is vaporization. Similarly, we have a latent heat of sublimation also, which means heat energy required to change the state of unit mass of a substance from its solid to vapor state. Remember, these all are at constant temperature and pressure. There is a particular latent heat graph for water given in your textbook. You can check what are the temperature or what is the amount of heat energy required to change water from a solid to liquid state, liquid to gaseous state, or a solid to vapor state. Likewise, so go through the textbook. It's in page number 285. Now let us discuss about different mode of heat transfer, different ways. This we have studied already in the lower classes. We have different mode of heat transfer, that is conduction, convection, and radiation. Conduction means through solid objects heat can pass. For example, a spoon dipped in hot water, when you touch it, you feel heat. because the heat energy is passed through the solid object, solid body. That heat transfer